Fire department.
Did they call about a fire right north of Greenway on 60th Street?
Okay, 60th Street and Greenway?
60th Street north of Greenway. There's a huge fire. It looks like something just exploded.
Do you know what's burning?
No, it's a house.
Channel 2, 211 assignment, house fire, 60th Street and Greenway, just north, engine 31, engine 37, engine 27, ladder 27, battalion 4.
Engine 31's on the scene of a medium-sized residency with the working fire engine 31's laying a line and going in with engine aft. Engine 31 will be commanded. Ladder 27 on the scene. Command ladder 27. Ladder 27. Ventilate utilities. Ladder 27 copies, ventilate utilities.
On July 1st, 1989, Phoenix Ladder Company 27 was operating at what appeared to be a routine residential fire. Supporting the first due company, Ladder 27 arrived on the scene about 10 minutes after dispatch. The incident commander ordered the 4-member crew to the roof to ventilate a working attic fire. 7 minutes later, as the crew was leaving the roof following a successful ventilation cut, the roof collapsed around them. The collapse sent one member completely into the well-involved attic space. The other 3 members dropped partially into the attic. All successfully extricated themselves and made their way off the roof. Minor burn injuries were sustained by only one member. This experience reflected a successful firefighter survival story as the result of proper wearing of full protective clothing, including gloves, protective hood, and the wearing of SCBA with the face piece on while working in a hazardous environment.
There's no doubt in my mind that I would be dead because I sucked in some of that air for a split second and I didn't like it. And I probably would have lasted 3 breaths and either I'd have been dead.
We cleared the tiles off, cut the hole, pulled the cut piece out, and as soon as we pulled the cut piece out, we got heavy smoke coming out, and it was like seconds after that we had fire just barreling out of there. So we scrambled, and I was towards the peak of the roof, and I think I went through first. Pete Hawking was behind me, and he went through about the same time I did, and he gave me a shove, and I kind of got up over the top of the roof, and then he went off on the north side. When Jeff saw me fall through, he came over. He tried to come over, and that's when he fell through. And then when I got pushed up over the top, I went over and helped him come out of the hole, and then we got off the roof.
Rick and I took a step. He was in front of me off to my right. He took a step and I took a step, and the whole roof just collapsed under us. I went forward to the ridge and I couldn't flip over. I was too deep into it. He was off to one side trying to get out, and I kind of pushed him and rolled back off at the same time, and then I slid down. And I think as I was going down, it was still spongy, or I was falling through, or the tile at least was all breaking up underneath my feet.
Without question, fire engineer Jeff Griffin is alive today because he was wearing his face piece while working above a fire. In addition, had either of the 3 firefighters who fell through the roof been wearing 3/4 height rubber boots, all would have received serious burns to the buttocks and thigh regions. Jeff Griffin was the only member burned. He received 2 small second-degree burns, one to the palm of the hand near the thumb and one to the buttocks. Both are believed to be conduction-type burns as the result of pressure contact with hot materials in the burning attic space. All of Jeff's protective clothing, including his helmet, received fire damage and was replaced. Some protective clothing of the other 3 firefighters and parts of 3 SCBAs also were damaged and replaced. This experience also identified the rapid collapse potential of lightweight wood truss construction once fire involves the truss space. In order to understand the roof collapse at this fire, a quick review of building construction is in order. Prior to the early 1960s, much of the roof framing for residential and commercial buildings in Phoenix were of so-called conventional construction. This type of roof structure is characterized by ridge beam and rafters of 2x4 or 2x6s that were angle cut at the top end and nailed to the ridge beam. Rafters were continuous, uninterrupted beam. Each rafter was nailed into place with large nails that penetrated all of the rafter and nearly all of the ridge beam. The importance of this deep penetrating nailing will become much clearer when we discuss the lightweight truss system. Suffice it to say, in order for the conventional framed roof system to fail, the rafters, ridge beams, or purlin members must either break or burn through. Failure of one member would not typically cause a catastrophic collapse, as is often experienced with a lightweight wood truss system. Conventional roof systems usually use 1x6-inch boards or 5/8 plywood as the solid roof surface, then covered with shingles or other roofing materials. The lightweight wood truss system consists of non-continuous members that are butted to each other and held together by metal nailing plates. When these plates fail, the connection is broken and the truss comes apart. These metal nailing plates hold all the truss joints together, and as a result, when the first truss connection fails, the whole truss can collapse, often causing collapse of adjacent trusses. These nailing plates have multiple teeth that are pressed into the wood members during a prefab assembly process. The depth of penetration of the teeth for the typical nailing plate is 3/8 to 1/2 inch. The truss materials are laid out on a jig, the plates laid in place, and then are pressed into the wood. The process is quick and inexpensive, but it can be deadly for the firefighter. The metal nail plate is the major culprit in early failure of the truss system. During exposure to fire, the metal absorbs heat very rapidly. This absorbed heat is immediately transferred to the metal teeth of the plate. As a result, the transferred heat quickly chars the wood around the teeth and weakens the grip the teeth have. In Ladder 27's fire, as the wood became charred, the nailing plates literally fell out, leaving the truss on the verge of collapse until weight or vibration caused it to fall apart. A cutaway of the 2x6 top cord and a 2x4 web member revealed less than 20% of the timber was charred. These members could have supported considerable weight for some time had the plates not fallen out or otherwise been weakened by the charring. Had this truss been assembled with deep penetrating nails, as found on conventional framing, instead of metal nail plates, the system would not have collapsed this early in the fire. A second most likely cause of early collapse of a lightweight truss system is failure of one of its web members. These web members are usually 2x4 inches and can quickly burn through. As already mentioned, failure of any one member of the truss system can cause the catastrophic collapse of the entire system. So what are the lessons learned regarding lightweight construction? First, if fire penetrates any lightweight truss space, expect early collapse. Collapse may occur with a few minutes of fire exposure and early in the time it takes to respond and begin firefighting operations. This can occur in residential and commercial buildings. Lightweight wood truss construction in commercial buildings is often characterized by wide-span flat roofs, but they can be incorporated into sloping or peaked roof structures and covered with a variety of roofing materials. Stay off the roof and get out from under the roof if the trusses are exposed to fire. Be aware that lightweight truss systems are used for floor assemblies and can also present this same hazard in multi-story buildings. Much of the roof construction since the mid-1960s for both single-family homes and commercial buildings involves lightweight construction. Watch out, they have a history of early collapse. Second, put the hazards of roof ventilation operations in perspective. Ladder 27's firefighter expressed a unique analogy following his experience. Operating on the roof is like climbing out on a tree branch. The further away from the trunk you go, the more likely that the branch will break. Third, the advent of positive pressure ventilation has and will continue to change the manner in which we ventilate fires. For the most part, positive pressure ventilation will eliminate the need for topside ventilation, or will allow us to obtain effective ventilation without going out on the roof to ventilate over the fire area. Do we really have to go out that far on the roof and over the fire to effect ventilation? Probably not.